So this little single board computer might very well be the thing that turns my Raspberry Pi into a piece of decor. Hello everybody, this is TechHut. In this video, what we are going to be doing is taking a look at the ZimaBoard. You may be wondering what makes this thing so special and how dare I degrade the almighty Raspberry Pi. Well, first, let's talk about the hardware. On the outside, we have two standard USB 3s, display out, and we have dual Ethernet. A little bit more on that later. Now, where this thing gets special is just about everything else. Taking a look at the back, we have two SATA ports allowing for additional hard disk or SSD expandability, which I do see some true NAS potential there. And what might be the most fascinating decision by the creator of this is the port right here on the side. This is a PCIe port, which allows for even more expandability and options. Specifically, this has 4 PCIe lanes, so you should be able to plug in capture cards, audio cards, network cards, Thunderbolt expansion cards, TV tuners, and more. Now, what I just plugged in here is an NVMe expansion card, in which I plugged in a Kingston 256GB SSD, and this little expansion alone added 8 times the original storage. And speaking of the original storage, what is actually in this thing? Well, there are 3 models ranging from $120 to $200 USD. The model I have here is the 832 or 8 gigs of RAM and 32 gigabytes of eMMC storage. For the CPU, we have a quad-core Intel Celeron processor with a base clock of 1.1 GHz with a turbo up to 2.2 GHz. The lower end configuration will have a dual-core Celeron with a slightly higher clock speed. Now, this isn't anything crazy when it comes to power, but for the size and what we'll be able to use this for, it's definitely no slouch. So this thing ships with a Linux distro called Casa OS. In the simplest terms, it's a Debian system that features Docker pre-installed and a beautiful web dashboard for you to easily manage your containers from anywhere on your network. Now, if you want to see my complete overview of Casa OS, I made a whole separate video featuring this board, so go ahead and check out that video down below. Now, what I'm going to do is go ahead and wipe Casa OS from this system. What I'm going to be doing is testing its capabilities with Proxmox and spin up some virtual machines. Proxmox is arguably the very best way to manage your virtual machines with all the specs, provided I should be able to spin up 1 or 2 machines, giving both of them 2 cores to work with. So I ran through the basic installation process. Proxmox is very easy to install. If you need a full guide and tutorial on that, I have a whole separate video. But now that Proxmox is installed, we could go ahead and boot into the dashboard. But first, we must thank the sponsor of today's video, Linode. If you're looking for a way to host Linux servers in the cloud, or you don't have the means to get your own hardware, Linode is a fantastic option for you. You have a wide variety of Linux distributions to choose from, a whole bunch of one-click web app installers, including WordPress, Minecraft Server, Ghost, Nextcloud, and many more. They feature a huge library of guides and tutorials, and 24/7 customer support to get you up and running. And better yet, if you use the link down below, you can get a $100 60-day credit to go ahead and try out Linode today. All right, hello. We are back. It's actually been a couple days since that initial recording. One thing, that Kingston NVMe SSD that I was intending on using was not compatible with the PCI little extender card I had, so I'm using a Western Digital instead. And 2, Proxmox is not a fan of being installed on eMMC memory or SDs or anything like that, so Proxmox is installed directly onto that Western Digital drive. With that, I did get Proxmox installed, so we're going to go ahead and log in, and there are 2 things that we are going to do to be able to, or what I'm going to do to test this. 1, we're going to create a container and install Pi-hole in it, and 2, we're going to create a virtual machine with Fedora Cinnamon, which I downloaded here, and kind of just test the general speed and snappiness of that in a graphical virtual environment. So first things first, we have the ZimaBoard here, so we're going to click on this, and we're going to head over to the shell. And what we're going to do is type in pveam, and we're going to update just to make sure that this is up to date. And we're doing this, we're in this shell anyways, because we're going to grab a template, because we need to run a template to be able to create containers. And we could see what templates we have available to us with the available command. So just type in available, hit enter, and then we will see the templates for, oh, it does help making sure you spell it right. There we go. And this is going to go ahead and show us the available templates we have. There's a bunch of turnkey stuff. I'm not going to dive too far into the details of this, but it's definitely something that's super cool and something we'll probably cover on this channel in the future. So for this, what I'm going to do is use a system template that I know is compatible with Pi-hole. We have Ubuntu, Gentoo, Fedora, a whole bunch of things. But what I think we're going to do is let's use this Ubuntu, let's do 2004 just to make sure that it's compatible with Pi-hole. This is the previous LTS, so we're going to give that a copy, scroll down here, and now instead of available, we are going to download this template here. So paste that on in, and we do need to specify where it downloads. So we're going to type in local because I'm going to download it to this local volume right here. So from there we can hit enter. And the cool thing about using containers in these templates is it uses a little bit less system resources. They're smaller in size because they're sharing the kernel with our actual root system here. And it is just about done. And we can see some of the status down here. So far, at least on the ZimaBoard, Proxmox is working perfectly fine. So what we're going to do now is create that container. Let's click create container, ZimaBoard. Let's give this a password. Hostname, we're going to go Pi-hole because that is the only thing that we're going to dedicate to this specific container. Template, we're going to go with that Ubuntu 20.04 container. Next. For disks, local LVM is fine. The disk size, let's up this to something like 32. Just give us a little bit more wiggle room, and we're good to go. So I should be able to close out of that, and right here we can see the little square for my Pi-hole container. Go ahead and click on that. We should be able to start this up. I believe this is root and the password. There we go. We are now in the really cool thing about these containers is if we go over to summary here, we can see right now it's using almost none of the CPU, that's expected. But on boot, it's only using 34 megabytes of the 4 gigabytes of RAM and just under a gig of total boot disk size. Absolutely fantastic. So here, let's add a apt update. Looks like I made a slight error. I'm going to go ahead and shut down this VM and fix that real quick. We go under network, let's edit this, and yeah, here's my issue right here. Need to check that, hit OK. And now let's start that up. And the boot speed on this is just crazy quick with these containers. There we go. We have the 40 IP address. So that's going to be important to know for a Pi-hole. Apt update. So we have 174 packages available to update. So let's do apt upgrade. And like right now it's doing a full upgrade. So it's going to be a pretty resource intensive process. And if we go over here, it's using about 50% of our CPU, 2 cores. And we're still under 100 megabytes of RAM. Absolutely beautiful. And you know what? While it updates, let's go ahead and prep our ISO for our virtual machine. So what we could do is go to the local volume right here. And under ISO images, let's go ahead and upload one because I already have it downloaded. Right here, this is the Fedora Cinnamon. So let's give that an open and upload this, about 2 gigabytes. Just about finishing up here, and it's done. And just for good measure, that was a pretty big update. Let's go ahead and reboot this server. Installing Pi-hole is real easy. We're just going to copy and paste this little bash script here. And I will note there'll be a full in-depth Pi-hole guide. Dang, this is a lightweight install. We don't even have curl. There we go. Let's try that again. All right. There is the beautiful Pi-hole logo. This installer will transform your device into a network-wide ad blocker. Okay, and showing everything works fine by me. Now again, I just like checking with this install running. If we go over to summary, still under 100 megabytes of RAM. Wonderful. There we go. There is our Pi-hole dashboard. Let's go ahead and log in real quick. Give this guy a copy and paste that on in. Log in. There we go. Beautiful. Now this is just super cool, that little ZimaBoard there. This is running in a container within Proxmox. Let's go ahead and log into my router real quick and see if this thing works. Advanced. All right, so let's change my static DNS here, 192.168.0.40. Let's just make that my secondary as well for now. Apply this. There we go. So now we can see some queries being added. Let's go to CNN real quick. There we go. I'm not seeing any ads load up. Well, any non-integrated ads. So if we go over to the Pi-hole dashboard, here we go. It's blocked over 50% of the requests after going out to a CNN there. So we can see it's working. It's working pretty good. So from there, let's go ahead and create a virtual machine. Click create VM, ID 1. Let's go. This is Fedora. Next, and for OS, all we need to do is select the Fedora Cinnamon image. Next. And generally, all of the defaults are good. Disk size, let's give this 64 for now. Next, let's give it 2 cores, the other 2 cores. Next, memory, let's give it the other half, so 092, I think? No, it's 96. Here we go. Check our video drivers, that's no surprise. And this is Fedora, so if I click on something like this and drag it around, you can see Fedora working perfectly fine. We'll go ahead and install this. I'll just skip ahead to when the installation is complete. Alright, that took a minute. Let's go ahead and shut down this VM here. So let's go ahead and start up Fedora, shall we? Alright, so there we go. We are now booted into Fedora after installing it. I went over to hardware and removed the ISO from the CD drive. And if we head over to summary, it is rating a little high. Looks like about 40% with 1.8 gigs, but it may be running some initial system updates and stuff. The CPU just dropped significantly, which is nice. If we go back to the console here, let's go ahead, open up something simple. Let's open up files, and yep, it's fairly responsive. It is running through VNC, so it's not going to be perfect. And this board really isn't meant to do this. I'm just kind of testing some of its capabilities here. If we go over to the entire board, we can see its entire CPU usage is about 45% running, or 30% running both Pi-hole and the Fedora operating system, using about 3 gigs of our 8 gigs and just under 5 gigs of our hard drive space. So a VM like this probably isn't going to be spun up all the time, so I'm going to go ahead and shut it down for now. Let's say yes, and it's going to process that. And Pi-hole is still running good with a ridiculous amount of RAM and CPU usage, and you can see it running right here just fine. The Pi-hole thing is a better use case for this Zima board than actually running a full GUI operating system. If you're going to set up Proxmox and set up a bunch of containers, based on the resources of this Pi-hole on this Ubuntu template alone, you're going to have crazy good performance, and you could spin up probably a good amount of these. So it looks like this is stopping. So if I go over here, you can see now the CPU is dropping rather heavily as that Fedora virtual machine goes down. So when it comes to running small containers like Pi-hole, Docker images, whether that be Nextcloud, TrueNAS, whatever you really want, this Zima board is a fantastic option, and I would recommend it for sure. So what we just did is a perfect example of a use case for this device, and it doesn't end there. On the website, there's much more examples, such as in industrial embedded projects. They have some badass examples of using this board on a remote control helicopter with AI recognition technology. Scary, but cool nonetheless. Now, what I'm going to be doing with this device on a permanent basis sooner rather than later is turning this into my network's modem with pfSense. With these 2 Ethernet ports here, pfSense should work perfectly fine. So make sure you subscribe and ring that bell so you do not miss that project. And if you're interested in trying this device out for yourself, it will be linked down below. Now, with all that, big thank you to the creators of ZimaBoard for sending this over to review first of all. And yeah, pretty cool thing. Have a beautiful day and goodbye.